In this video, I'm going to be applying game theory to a real life situation. My application is when me and my sister are getting ready to go for a day in the mountains. I prefer skiing while she prefers snowboarding. However, we both prefer to do the same activity together than do one on our own. We don't see each other before we get out because she always gets up after me. We can condense this information into a table with rows representing my actions and columns my sister's. The first number in each cell corresponds to my payoff and the second number my sister's. First, we're going to make some assumptions. We're going to assume this is a normal form game, and hence me and my sister both make our choices simultaneously. We're going to assume no collusion, perfect information, and rationality. We're going to start by looking at my actions. Assuming I know my sister will go skiing, I'll also choose to go skiing, since 10 is a higher payoff than 0. However, if I know my sister will go boarding, I'll also go boarding, seeing as 5 is a higher payoff than 0. So the action I pick will depend on what action my sister chooses. Neither of the actions that I can choose dominates the other. Again, now looking at my sister's actions. If my sister knows that I have chosen to ski, she'll also choose to ski, seeing as 5 is a higher payoff than 0. However, if my sister knows that I have chosen to snowboard, she'll also choose to snowboard, because 10 is a higher payoff than 0. The action that my sister chooses will depend on what action I have chosen, as neither of her actions dominates another. We can now clearly see there are two pure strategy Nash equilibria: skiing, and boarding. If we are at the Nash equilibria skiing, and either of us deviates the action we have chosen while the other person's actions hold, we will both receive a lower utility. The same can be applied to the Nash equilibria boarding. This game is known as Battle of the Sexes. For this game, there is also Nash equilibria in mixed strategies. We're going to start by solving the mixed strategy for me, or player 1. We do this by saying, what is the utility for my sister if she always goes skiing? So some percentage of the time P, my sister will get a utility of 5, while the rest of the time she receives utility 0. We do the same for if my sister always goes boarding. So some percentage of the time P, she will receive utility 0, and the rest of the time utility 10. To a mixed strategy, these two things need to be equal to each other. And by algebraic manipulation, we can solve for P and get the probability that I will ski is 2/3 and the probability that I'll board is 1/3. We can then use the same method to find my sister or player 2's mixed strategy Nash equilibria. She will ski with probability 1/3 and board with probability 2/3. This can be summarised in this table. Battle of the Sexes is interesting because of the mixed strategy Nash equilibria. It is inefficient and Pareto inefficient, so there will be equilibria that improve utility for both the players. If this game is played just once, it is likely that either outcome could be reached. However, in reality, the game will be played more than once. Collusion is likely, and therefore the two players are likely to cooperate on an outcome that will benefit them both. For example, skiing and then boarding.